Hello students, I am Dr. Tanmay Vishwas. I welcome you all in my channel Tanmay Kim. Today's topic of discussion is on MCQ and the question is in front of you. As usual, I request everyone please pause the video, try by yourself, and whatever answer you get please write in the comment box along with few words as explanation. I believe you have tried, so let's start. Now, MCQ. What will be the product of this reaction? This reaction means this is dichloro-derivative reacts with antimony pentachloride and it's a product. So what are this product? Before going to the details, let's learn. SbCl5 or antimony pentachloride is a very strong Lewis acid. Now if you look at antimony, it belongs to group 15 like nitrogen, phosphorus, like that. So it has maximum 5 electrons and that's utilized to make this compound antimony pentachloride. Okay, so it's actually maximum oxidation state. Next, so plus 5, and if you look at very high electron deficient because plus 5 oxidation state, so that's why it can act as a very strong Lewis acid. So okay, it will prefer to form adapt with Lewis base or electron rich substance. If you look at each of the chlorine, they have 3 lone pairs of electrons. So what happened? At least one could be donated to one antimony. By the way, here 2 SbCl5 given. So what happened? So first it coordinates. After that, this chlorine get a formal positive charge, means deficiency of electron. Consequently, what happened? This bond breaks very easily. Same thing happened for the second chlorine. So it produces this dication. Now your question will be, sir, carbocation, they are reactive reaction intermediate, and by the way carbon is not a very high electropositive element, so how this positive charge is stabilized? Not only positive charge, 1 2 position, 2 positive charge adjacent to each other. What's unique stability there? And this is actually stabilized by a very special rule named as Huckel rule, means it is actually aromatic. What is the criteria of a compound to be aromatic according to Huckel rule? That is, compound must be cyclic, it is. Compound must be planar, yes it is. Each atom must have a p orbital. Now if you look at this positive charge, they are actually vacant p orbital, means this carbon has vacant p orbital, this one same, and every other carbon atom, if you look at, everyone has p orbital and it has 1 electrons. Now, and fourth, if 4n plus 2 number of pi electrons there, it must be aromatic. Aromatic means stable. And if 4n pi electrons are there, anti-aromatic means dead cell. But in this case, if look at, this is aromatic, means it is stable. Now if you look at, there are 2 pi electron here, here also 2 pi electron, here also. So each of the pi bond represent 2 pi, 2 pi, 2 pi. So in total 6 pi electron. By the way, positive charge means deficiency of electron, no electron, but p orbital is there, so that can participate in resonance. Means you may say, sir, this can come here, positive charge will go there, even this can also participate this way, positive charge will come there. In this way, the positive charge will delocalize all over the ring. By the way, I'm drawing one canonical form, means the first one. So how to draw the cycloocta tetraene or cyclooctene derivatives? So this is, and now connect them this way, and I would suggest student do a numbering, it helps a lot. Okay, so it is 1 2 3 4 5 6 7 8. So first canonical form only, so the positive charge goes at carbon number 3, remaining things will be there as it is. So this is, now you can draw many other canonical forms. I suggest you student please practice this by yourself in home. In conclusion, if I say the positive charge, 2 positive charges distributed all over the ring and they are in conjugation or delocalization. So what will be the major product? Obviously dication species, option B. Now if this question appear in your exam less than 30 seconds, how could you solve? First you need to understand antimony pentachloride plus 5 oxidation states, so very electron deficient. Actually it doesn't have more electron left to be donated, so its maximum oxidation state is plus 5. So you may expect, sir, it can't act as a reducing agent or electron donor. It can act as oxidizing agent or Lewis acid, but it can't give electron and reduce someone. So obviously 2 minus, how 2 minus could be produced? Means obviously if it get electron from where? Antimony pentachloride, which is not possible. Now even if you look at, this is also a reduction, this CCl is student reduced and ultimately CH is produced. Obviously the previous hydrogen is there as it is, along with that there are 2 new hydrogen atom on the 2 carbon atoms. So this is also not possible because I have not used any reducing agent. It is a Lewis acid. So obviously only one option left, that is this. Now if I say option A not possible, option C not possible, so obviously here is A, so it is also not possible. By the way, if you do not know the right answer, also by this back calculation, or it is called as process of elimination, you can conclude the right answer. So in this way also you can get the right answer. But I believe, student, it's a very famous example, well established example, please try to remember it. Okay, so in conclusion, what you have learned that SbCl5 or antimony pentachloride is a very strong Lewis acid, and it can abstract chloride ion and produce a carbocation. Actually here two equivalent, two chlorine, so dication. And remember, carbocation is a reactive reaction intermediate, and its stability decides about its formation and the reaction condition. And finally, remember, it's a very important point that aromaticity is a very high stability, because in case of aromaticity, the extent of delocalization of electron is maximum. As I shown, many canonical forms possible where the 6 pi electrons are delocalized or distributed over all 8 carbon atoms. So the delocalization is maximum. That's why the resonance is also very high, means stability is also very high. That's why this dicationic species, means 2 electron deficient species, also have significant stability and it produces. Okay, so this is the overall discussion. Thanks for watching. See you in my next video. Bye bye.